Hello everyone, and welcome to 7th episode of Analytics Bytes series, a video series where we explore common analytics use cases and how to architect for them. My name is Manish Chugh, and I'm your host today. I'm a principal solutions architect on a startups team here at AWS. I'm based out of San Francisco office, and in my day-to-day activities, I help my startup customers build, deploy, and run scalable and cost-effective workloads on AWS cloud. In today's episode, I'm going to talk about how to train and deploy your machine learning models using Amazon SageMaker, and also how to design and integrate modern data architecture with SageMaker for machine learning predictions. So let's get started. Just to recap, modern data architecture allows startup customers to think big, start small, and scale fast. It helps modularize architecture, increases your agility, and help scale quickly as your business grows. You can easily add new data sources, scale the workloads up and down, and add new analytics workload when the business demands. In the previous video of Analytics Bytes series, we talked about modern data architecture and various segments of modern data architecture such as serverless data lake, streaming data ingestion, transactional data lake, Redshift, and how to prepare data for machine learning using Amazon SageMaker. In these videos, we covered specific use cases, reference architecture using AWS services, and customer success stories. In today's video, I'll talk about how to use SageMaker in building, training, and deploying your machine learning model and integrate with modern data architecture. SageMaker includes a lot of different features and capabilities. We typically talk about these features and capabilities into 4 different categories: data preparation, model build phase, training and tuning, deployment, management, and hosting. In the previous video, we talked about different ML data prep capabilities of SageMaker, such as SageMaker Data Wrangler, SageMaker Feature Store, and SageMaker Ground Truth. We also talked about SageMaker Studio notebooks as well as SageMaker Studio itself, and how they can help in building and prepping data for machine learning. In today's session, we'll talk about how SageMaker helps in training, tuning, deployment, and managing machine learning models in production. First up, let's discuss how SageMaker helps in building ML models. SageMaker offers ML engineer and data scientist, as we talked about Studio IDE, as well as the notebooks, which are the starting point for your model build phase. SageMaker also allows your ML developers to pick different algorithms, including over 20 that are built in and optimized for SageMaker. It also offers over 300 pre-built models from popular models available with just a few clicks, and over 15 pre-built solution templates. Amazon SageMaker also offers a feature called Autopilot for customers who wants to automatically build, train, and tune the best machine learning models based on their data. You then can directly deploy those models to production with just one click or iterate to improve the model quality. SageMaker also optimized for many popular deep learning frameworks such as TensorFlow, Apache MXNet, PyTorch, and more. Frameworks are always up to date with latest version and are optimized for performance on AWS. You don't need to manually set up these frameworks and can use them within the pre-built containers. Now let's talk about what capabilities SageMaker provides to train these models. SageMaker provides full set of managed training capabilities. It reduces the time and cost to train and tune machine learning models without the need to manage the infrastructure. With SageMaker, you can easily train and tune ML models using purpose-built tool to manage and track training experiments, automatically choose the optimal hyperparameters, debug training jobs, and automatically monitor utilization of system resources such as GPUs, CPUs, and network bandwidth. All steps of training workflow can be automated into machine learning workflow, so you can scale to thousands of training experiments. SageMaker also offers the highest performing machine learning compute infrastructure, including P4D instances, which provides up to 60% lower cost to train machine learning models compared to previous generation instances. SageMaker automatically scales training infrastructure up and down based on your training job requirements, from GPUs, from one GPU to thousands, or from terabytes to petabyte of storage. Therefore, you don't need to worry about managing the infrastructure, and since you only pay for what you use, you can better manage your training cost. To make training faster, you can enable the SageMaker training compiler and immediately achieve up to 50% speed up through graph and kernel level optimizations, which makes more efficient use of GPUs. Also, the SageMaker distributed training libraries automatically split models and training datasets across GPU instances, helping you complete distributed training up to 40% faster. Wow, a lot of features there to help you do your training. Now let's explore the capabilities and benefits of SageMaker for deploying these ML models for inferences in production. SageMaker makes it easy to deploy and manage machine learning models at scale. As a fully managed service, it takes care of setting up and managing instances for inferences, ensuring software version compatibilities, and patching versions. SageMaker also provides built-in metrics and logs for your endpoints that you can use to monitor and receive alerts. SageMaker also offers more than 70 instance types for your inferences with varying level of compute and memory, including Amazon EC2 Inf1 instances based on AWS Inferentia, high-performance ML inference chip designed by AWS, and GPU instances such as EC2 G4DNs to meet the performance and cost requirement of any use case, including real-time, high-throughput batch inferences. SageMaker also allows developers to access deployed models through API requests with response time as low as few milliseconds. This supports use cases requiring real-time responses such as ad serving, fraud detection, and personalized product recommendations, to name a few. For inference requests that take longer than real-time or maybe real-time and near real-time, SageMaker offers asynchronous inferences, which supports processing times up to 15 minutes and payloads up to 1 gigabyte. Async inferences are best suited for use cases requiring real-time user experience, but use large computer vision or NLP models. SageMaker also provides scalable and cost-effective ways to deploy your machine learning models, whether it is one model or large number of models. SageMaker multi-model endpoints and SageMaker multi-container endpoints enable you to deploy hundreds of models on a single endpoint, improving the cost effectiveness while providing the flexibility to utilize models as often as you need them. For use cases with intermittent inference requests, SageMaker serverless inference automatically provisions scales up and down ton of compute capacity based on number of inference requests. SageMaker serverless inference service automatically removes the need to manage complex scaling workflows by ensuring the exact amount of resources are available for inference to save time and money. For all other use cases other than serverless use cases, you can use auto scaling in SageMaker policies to elastically scale the underlying compute resources to accommodate fluctuations in inference requests while reducing the cost. SageMaker model deployment features are natively integrated with machine learning operations capabilities. As a result, deploying one model or tens of thousands of models, SageMaker helps offload the operational overhead of deploying, scaling, and managing ML models in production while also getting your models to production faster. SageMaker also allows you to implement advanced deployment capabilities for machine learning, such as A/B testing, canary deployment, blue-green deployment. Using these techniques, data scientists can rapidly release model updates, avoid downtimes during deployments, and benchmark the performance of their ML models in development, test, and production environments. SageMaker Inference Recommender, a service which is optionally available to you to automatically select the optimal compute instances and configurations. To deploy your machine learning models, SageMaker Inference Recommender reduces the time to deploy from weeks to hours by automatically recommending the ideal compute instance configurations and model optimization. Machine learning lifecycle does not stop here. Once models are deployed, they need to be monitored for quality and performance and retrained when new data is available or the business and user dynamics changes or there is a bias detection. So model or drift detection. So model development and deployment is not a one and done task. Handling the iterative nature of ML lifecycle requires MLOps practice. That brings us to the next component of Amazon SageMaker. Amazon SageMaker offers the MLOps capabilities. It helps you automate and standardize MLOps practice across your organization. SageMaker Pipelines is a fully managed feature that helps you automate and orchestrate different steps of machine learning workflow. SageMaker projects specifically brings CI/CD capabilities to machine learning, such as maintaining parity between development and production environments, source and version control, automated testing, and end-to-end automation. With SageMaker Model Registry specifically, you can track model versions, their metadata such as use case grouping, and model performance metric baseline in central repository. SageMaker logs every step of your workflow, creating an audit trail of model artifacts such as training data, platform configuration, model parameters, and learning gradients. SageMaker Model Monitor specifically detects model drift, concept drift in models deployed in production in real time. And it's also integrated with SageMaker pipelines and model registry, allowing you to automatically schedule model monitoring as part of CI/CD pipeline. SageMaker offers a comprehensive set of security features as well, including infrastructure security, data protection, authorization, authentication, and auditability to help your organization with security requirements that may apply to your machine learning workflows. Whew, a lot of features available for MLOps. Now that we have talked about how SageMaker can help in training, tuning, and deploying your ML models, let's talk about how to integrate SageMaker endpoints with modern data architecture to bring everything together. First up, we have predictive maintenance use cases where sensors deployed in the field need to be replaced or rectified before they become faulty or cause you downtime. So device sensors stream various measurements and readings about your machine parts to Amazon Kinesis data stream as shown on the diagram. This example solution then takes a slice of streaming data each time and performs processing and feature engineering to create new features. The created features are then used to generate inferences from trained and deployed ML models in near real time using SageMaker endpoint. The generated inferences can be further processed and consumed by downstream application to take appropriate actions and measures to initiate maintenance activity. One of the biggest challenges is to cope up with the amount of data, and the value of that data diminishes over a period of time. The challenge is to analyze, learn, and infer from the real-time data to predict future state, as well as to detect anomalies and get accurate results. In this second example, we are using Amazon Kinesis Data Analytics for Apache Flink with Amazon SageMaker and Apache Flink using API Gateway to address the challenges such as real-time fraud detection on a stream of credit card transaction data. Data is ingested in Kinesis data stream using Kinesis producer library. And then Kinesis data stream then streams the data to Apache Flink-based Kinesis data analytics application. Kinesis data analytics manages the required infrastructure for Flink and scales the application in response to changing traffic patterns and automatically recovers from underlying failures. This is a perfect setup for real-time in-stream inference using SageMaker. As discussed, typical machine learning workflow involves processes such as data extraction, data pre-processing, feature engineering, model training, and evaluation, and deployment. As data changes over time, when you deploy models to production, you want your models to learn continuously from the stream of data. This means supporting the model's ability to autonomously learning and adapting in production as new data is added. In practice, data scientists often work with Jupyter Notebook for development work and find it hard to translate these notebooks into automated pipelines. To achieve the two main functions of ML service in production, namely retraining and inference, you can use this example. This example demonstrates how to orchestrate an ML training pipeline using AWS Glue workflows and train and deploy the models using Amazon SageMaker. For this use case, you can use AWS Glue workflows to build an end-to-end machine learning training pipeline that covers data extraction, data processing, training, deploying the models to Amazon SageMaker endpoint. Pretty cool. Analyzing, transforming, and preparing large amount of data is foundational step for any data science project. Data scientists and data engineers sometimes use Apache Spark, Hive, and Presto running on Amazon EMR for fast data preparation. SageMaker Studio comes with built-in integration with Amazon EMR, enabling you to do petabyte scale interactive data preparation and machine learning right within the Studio Notebook. In this example of predicting the sentiment of a movie review, you can run an end-to-end ML workflow, including preparing data, monitoring Spark jobs, and training and deploying an ML model to get prediction, all from the same Studio Notebook. SageMaker provides an Apache Spark library in both Python and Scala that you can use to easily train and tune your models in SageMaker before deploying at an endpoint. Very powerful. Another example can be natural language understanding powered search application using SageMaker and Amazon OpenSearch, which was previously known as Amazon Elasticsearch. Regular Elasticsearch text matching search is useful when you want to do a text-based search, but k-nearest neighbor based search is more natural way to search for something. For example, when you search for a wedding dress using a KNN based search application, it gives you similar results if you type wedding dress or marriage dress. This example demonstrates two phases of this application. First, building the KNN reference index and then querying the index for results. So using Amazon SageMaker with OpenSearch service for KNN index feature, you can have KNN based search application which can connect to any front-end user experiences. Last but not the least, in this final example, you can also connect Amazon SageMaker Jupyter Notebooks to the Amazon Redshift cluster and run data API commands in Python. This in-place analysis is an effective way to pull data directly into Jupyter Notebook object and then apply transformation on for further understanding, processing, or feature engineering. The Amazon Redshift data API makes it easy for any application written in popular programming languages to interact with Amazon Redshift. After exploring, you can implement machine learning models in Amazon SageMaker using data stored in Amazon Redshift cluster. You can make use of data build, train, and test an ML algorithm in Amazon SageMaker And finally, you can deploy that model in Amazon SageMaker instance and draw inferences. These are just a few examples. There are hundreds of different use cases and examples are out there. Or the different ways you can integrate SageMaker in modern data architecture for machine learning predictions. This brings us to the end of this episode. Information shared here is just a tip of an iceberg. To learn more about modern data architecture and SageMaker, please watch other episodes of this series, and please do check out the link shared below. In the next episode of Analytics Bytes series, we'll talk about real-time search and log analytics with Amazon OpenSearch. Thank you again for joining this episode of Analytics Bytes series. We'll see you in the next one. Goodbye.